All right, so we're starting a new unit, and now we're working on Unit 12, Equations of Circles. Now, this unit, we're going to be doing a lot more of the algebra stuff, but we're also looking at some of the geometry that we did with lines and equations. So you're going to have to remember a lot of that. A lot of our old material from early in the year is now coming back into play. So without further ado, let's talk about equations of circles. Okay, so you've got your worksheet here again. If you didn't get a chance to print this out, make sure you print this or just take notes on regular paper. That's fine too. Either way you want to take notes, that's best for you is what you should do. So our equations of circles, let's start off with something that we've done before. Let's talk about our distance formula. Okay, so you got to remember your distance formula from way back in earlier in our year. Let me get a better color here. There we go. So our distance formula, remember that was the distance equals the square root of x2 minus x1 squared and y2 minus y1 squared. And we said it was basically a fancy form of Pythagorean theorem. So if we want to find out how long segment AB is, that's this segment here, then what I want to do is actually use these points for my x1, y1, x2, y2. So I'm going to set up my distance formula and substitute those in. So x2 is 8 minus a negative 3 turns that to plus 3. And then 17 minus 4 squared. And that's pretty simple arithmetic now. Now it's basically just doing algebra. So 8 and 3 is 11. 17 minus 4 is 13. We're going to square that. So that's 101 and 169. And I went ahead and did the arithmetic a little earlier and found that to be square root of 290. So I'm just going to leave that there for now because that is how big this radius is. Square root of 290. So instead of calling that d for distance, I could call that r for the radius of the circle. We now found the length of the radius of that circle. So a very simple thing, using that distance formula to calculate the radius. Because remember, radius is a couple ways to define it. You can define it as a segment from the center of a circle to a point on the circle, but you could also define radius as the length of a radius. So it's a weird way we can use the same word to say two different things. So let's take that same idea, that same formula, and apply that. Instead of having points A and B, let's apply it to points C and P here. So we're doing the same formula. We're still using our distance formula. I'm going to rewrite that. Again, the more you rewrite your formulas, the more likely you are to remember them. So I'm going to rewrite my formula. And now I'm going to substitute HK and XY. So my distance equals, and you know what? Instead of calling it distance, since we already said it's going to be the radius, I'm going to call it r for radius. The square root, and my x2 is just x. My x1 is h. My y2 is y, and my y1 is k. So what we've done there is we've said, well, this point C, this is the point HK. And this point P is XY. What that means, that point P could be anywhere on the circle. It's any XY point that's on the circle. HK, however, is the center of the circle. What we do now, let's say that I were to take this and square both sides of this equation, because we learned in algebra you can do the same thing to both sides. That's going to leave me with an equation that now says the squared and square root cancel each other. X minus h squared plus y minus k squared equals r squared. This is our formula for an equation of a circle. Okay? And in that circle, it tells us a couple things. It tells us that we have center HK. So that's the center of the circle. And R is my radius. Now it's going to be R squared. So like in the problem we had up above, let me slide up here. in this problem, r is square root of 290. But if I were to put that into my circle formula, if I were to put that into this formula, the square root of 290 squared would just equal 290. Okay, so you got to be careful that you're making sure to do that properly. This is a formula you want to memorize, okay? This is definitely a formula that you want to memorize. Commit that to memory. You need to know this. But again, if you really look at it, look at what it is. It's nothing more than, well, we already said it's a distance formula, but also look at what it is. It's an a squared plus a b squared equaling a c squared. It's a secret version of the Pythagorean theorem. That's really all that the circle formula is. Because when we look at the circle, you're finding that radius by just calculating the hypotenuse of that right triangle. And this point P could be anywhere on that right triangle. If I put that same point P over here, well, now I just have a different right triangle. In fact, that's a bad decision because it's horizontal. But if I put that point P over here, I now have another right triangle. It's the same. In fact, they're congruent right triangles. Okay? So that's how we can use Pythagorean theorem or the distance formula to create our circle formula. Once we know that and we know the shortcuts, well, that's the whole thing about mathematics. I learn things so I can do shortcuts. Because now they give me a formula. And from this formula, I can find the center. So my center, what do you think it is? Hopefully you said 7. Whoops, I got to get a pen here. 7, negative 10. Now, one of the mistakes people tend to make is that they'll say negative 7, positive 10. But remember, my formula actually does the opposite of what you think it does. Okay, so when I look at my formula up here, it's already set up as minus h and minus k. So h and k are my points for my center. So minus h, so there's my h. H is 7. But because that says plus, the only way I can take a minus sign and get plus into it is to make it a negative 10. Okay? In other words, what this is saying, if I broke this out to look a little more like this formula up top, there's x minus 7 squared plus y minus negative 10 squared. Okay? So look out for things like that. The radius, what do you think the radius is? Hopefully you said that the radius is 9. Because remember, this 81 is r squared. So r is the square root of 81, and the square root of 81 is 9. Okay, so that's how you can take a formula and find the center and the radius of a circle just by looking at the equation. What about if I want to write the equation? So if I want to write the equation of a circle, the two things I need to know are my radius and my center. Okay, so looking at circle A, what is the center of circle A? Well, if you look at circle A, you should see that I'm going to start at my 0, 0. Here's my 0, 0. I'm going to come over 2, up 3. Be careful of your scale, okay? So that's going to be 2, 3 for my center. So my center is at 2, 3. To get the radius, I just need to count. There's a point down they put down here, so I can count to that point. So that's 1, 2, 3, 4, 5, 6, 7. Notice I'm counting each one, right? Because my scale is 2, so I'm counting that as 1, 2, 3, 4, 5, 6, 7. So that means my radius is 7. Taking those points now, write the equation for your circle. Okay, so you should have x minus 2 squared, don't forget the squared, plus y minus 3 squared equals 49. Don't leave that as 7 squared. You know what 7 squared is, so go ahead and calculate it. Okay? Very simple. Try circle B. Write the equation for circle B. So the first question is asking you, what's the radius? And what's the center? That's the first thing you need to find, right? So my radius, let me see, let me get my counter here. It's going to be 1, 2, 3, 4, 5, 6. So a radius of 6. And my center is going to be from 0, I'm coming over -7 and nothing up and down. So that's -7, 0. When I write that out, that's going to be x plus 7. Remember, minus a negative is a plus. And then plus, I can just write y squared. You don't have to write y minus 0 squared. If you did, that's fine. I'll accept that. But you can write just y squared. And then, of course, 6 squared is 36. There's the equation of my circle. Okay? So we can now do two things with the equations of circles. We can very easily take an equation, find the center and the radius, or I can take a picture, find my radius and my center, and write the equation. One more thing we want to be able to accomplish with circles, and that is to actually sketch a circle. Okay. Well, before we get there, let's take a written problem. Now we've got one without a picture. So this problem, using a diameter and a center, I want to find the equation of the circle. So we already have our center. Go ahead and give me what you think the equation is going to be. Okay, so you've got your center, so that makes life a lot easier. So it's x plus 3 squared, don't watch that plus sign, plus y minus 6 squared. By the way, notice that because this is like Pythagorean theorem, the sign in the middle is always plus, okay? That's my a squared plus b squared. So that sign is always going to be plus. It's the ones here you have to look out for, okay? A lot of people like to say, hey, I'm just going to use whatever is the opposite of there. That's how some people like to think about it. Now I need to get my radius. Be careful. Your radius is not 14. Your radius is 7, okay? But again, be careful. You don't want to say 7 squared or 7. You want 7 squared, which is 49. And there's my equation. Okay, so let's try one more little thing. Let's sketch a graph. Okay, now when you do this on a Desmos assignment you're going to have, you can actually use your finger to draw on your screen to sketch the graph. For this, a little bit of information we're going to try. And if you don't get perfect circles, don't worry about it. I can't draw a perfect circle either. So let's see. First thing I'm going to do is just like I do every problem. Identify the center, identify your radius. Always put parentheses around your center. So my center is at 3, -2. My radius is 2. Okay, so I'm ready to go sketch that now. So I'm going to sketch my center. So that's over 3, down 2. So I'm going to put my center here. Now, when I sketch the circle, the radius of 2, I'm going to make 4 points, basically north, south, east, and west. So I'm going to go up 2 from my center. I'm going to go over 2 from my center, and down 2 from my center, and over this way 2 from my center. Those 4 points I'm going to connect in something resembling a circle. So I'm going to do the best I can to get a circle here. There we go. If it doesn't come out perfect, who cares? But there we are. We have our center and our radius for that circle. Okay? So very simple problems. Your job now, there's going to be 2 things that you need to accomplish. There's going to be a Desmos. When you get each slide of the Desmos, once you have your answer, click to the next slide. Once you're all done, you can just quit it. It saves automatically. I'll go in and be able to see what you did. And then after that, there's also quizzes. The quizzes are done like they're always done. Remember, quizzes have a deadline, so make sure you do it by the deadline, okay? Otherwise, they lock you out, okay? That's what we got on equations of circles. Tomorrow, we'll talk about a little bit of algebra review that we're going to need to do the next part of equations of circles, okay? Have a great night. Bye-bye.